Fourth model that we are going to learn is safety stock. When EOQ assumptions are met, it is possible to schedule orders to arrive so that stockouts are completely avoided. However, if the demand or the lead time is uncertain, the exact demand during the lead time, which is the ROP, reorder point in the EOQ situation, will not be known with certainty. Therefore, to prevent stockouts, it is necessary to carry additional inventory called safety stock. One of the best ways to implement a safety stock policy is to adjust the reorder point. In the EOQ model, where the demand and lead time are constant, the reorder point is simply the amount of inventory that would be used during the lead time. This is assumed to be known with certainty, so there is no need to place an order when the inventory position is more than this. However, when the daily demand or the lead time fluctuates and is uncertain, the exact amount of inventory that will be used during the lead time is uncertain. The average inventory usage during the lead time should be computed, and some safety stock should be added to this to avoid stockouts. And we are going to consider this situation and see how we can calculate the safety stock together. So safety stock is going to depend on service level, what kind of service level you want to maintain. You want to have 99% of inventory or 95% of inventory or 90% of inventory. And that's a very important decision. If your business is really high quality and focused on customer satisfaction, having like 99.999% of service level is the best. However, it's a lot of inventory, and carrying safety stock that much would be a very risky proposition. So as a result, you want to determine what safety stock level you want to maintain for your business. So service level equals 1 minus probability of a stock out. And if you just manipulate this formula, you see that if you add probability to the right and to the left and subtract service level from both sides, then you get probability of stock out equals 1 minus service level, right? So that's what you get from safety stock. And then you can calculate the reorder point, that is average demand during lead time plus the Z distribution at the demand during the lead time. So SDLT stands for standard deviation of demand during the lead time. So what is the standard deviation or risk factor during the lead time that you want to know? If you know that, then you can calculate that ROP easily. So safety stock will be this Z times SDLT, so number of standard deviation for a given service level times standard deviation of demand during the lead time. So they come together, and that's going to be your safety stock. So let's take an example here, Hinsdale Company. And this company carries a variety of electronic inventory items, and these are typically identified by SKU. One particular item here, A3378, has a demand that is normally distributed during the lead time with a mean of 350 units and a standard deviation of 10 units. And Hindales wants to follow a policy that results in a stockouts occurring only 5% of the time on any order. So that's 5% is the failure rate, and so the service level is 95%. And using this one, how can you calculate this? So the first thing is that you have to understand how to find this X value, right? So your mean is 350 and your standard deviation is 10, and 5% of stockouts you want to have, and 95% of service level you want to maintain at the time, what is the value of X, right? And that can be easily found actually if you use Z-table, and you see that 95% or your right tail is only 5%. At that time, the corresponding Z value is 1.65. So that's what you can find. And therefore, reorder point will be average demand during the lead time is 350, right? So that's 350, and plus one Z value at the service level of 95% is 1.65, and multiplied by the standard deviation, which is SDLT, is 10. It's given there. So if you add them up, 366.5 units or 367 units are your reorder point. So whenever you reach 367, you want to order your EOQ amount because it takes time for you to receive your order, and you need to ensure that stockouts would not happen, right? So, and this will cover 95% of service level. And if I just give you a tip, if you use this formula, norm dot inverse function, then you can find the x value very quickly. So it says norm dot inverse and then 0.95 and 350 and 10 you enter, then 366.5 comes out right away. So you can use this function for this kind of problem and calculate it quickly. Lead time, demand, and safety stock. So we have looked at cases, but there are three different cases that we need to consider. The first one is demand is variable, but lead time is constant. So we know, more or less the lead time is 5 days or 7 days or 15 days, and that you have a pretty reliable transportation and work system. So then this is the case where demand is fluctuating and you are not so sure what it'll be, but lead time is constant. In that case, you want to use this function, reorder point equals D bar, or average daily demand, times L. L is lead time in days, plus a Z value that we discussed before, times sigma D, standard deviation of daily demand, and square root of lead time. If you use this function, you will be able to find your reorder point quickly. And the second case is demand is constant and lead time is variable. For some reason, you have steady demand, say 100 units per day, and it's quite constant. However, you are not so sure about the lead time. Sometimes you get your products from your supplier A and B and C, sometimes E, or randomly you go about and get products. In the case, the lead time is variable because each suppliers might have different policies and distances and circumstances. So in that case, you are going to use this function called ROP equals D times daily demand times L bar, so average lead time, plus Z value times D times sigma L, right? Daily demand times sigma L means standard deviation of the lead time. So you have various lead time and you calculate the standard deviation, and then you will be able to find the ROP for this case. The third case is both demand and lead time are variable. So, your daily demands are changing and your lead time are changing all the time. And what should you do? You want to use this generalized form of ROP, which is D bar times L bar plus Z value times square root of L bar times sigma squared plus D squared times and the standard deviation of the lead time squared. So that's the function that you want to use. And let's see this example. So first one is determining SQF 5402, and we want to determine the safety stock for the first case where the demand is changing but lead time is constant. And we learned that the daily demand is 15 and mean is 15, and a standard deviation is 3 and lead time is 4 days, so it's a constant. However, the daily demand can change with a sigma being 3. And the desired service level, say it's 97%. Therefore, if you find the corresponding z-value, it's going to be 1.88. And one tip for you is you can use norm dot inventory or inverse, I'm sorry, not inventory, norm dot inverse function and 0.97 as a probability you put in that corresponded to this desired service level, then you get 1.88 as your z-value. So you can find it quickly, and then you can apply those numbers into this ROP reorder point formula. So D bar is given as 15, and L is given as 4, and the Z you found 1.88, and the sigma for the daily demand was 3, and a square root of the lead time, which is 4, and you calculate that, you get 71.28. So probably when you reach 71 or 72 units, then you have to use your UQ amount of inventory right away. So that's case 1. And case 2 is, lead time is variable and daily demand is constant. So demand is given as 25, and the lead time, the average lead time or lead bar, L bar equals 6, so it takes 6 days, and the standard deviation for the lead time is about 3 days. So sometimes it takes 9 days, sometimes 3 days, sometimes 12 days, sometimes just it comes right away, right? So that's what it means by the standard deviation being 3 days for your lead time. And the service level is 98%. If you use norm.inverse function, you will find that Z is 2.05 and plug these numbers in. Your daily demand is 25 times 6, the average lead time, and plus the Z value 205 times 25, which is daily demand, and times the lead time for the sigma for the lead time, and you plug them in and calculate, then you get 303.75 in this case. So you might want to have 304 as your reorder point. The third case is both daily demand and lead times are changing and they are variable. So you collect the data and calculate the daily demand and average demand and average lead time, and also the sigma standard deviation of that variation, and you found it is 4 for daily demand, and for lead time it's 2, and you have 94% of service level as a target. And if you use again norm dot inverse 0.94, then you'll have Z equals 1.55, and you plug these numbers into your formula. ROP equals DL bars plus Z times square root of L bar times sigma D squared plus D daily demand squared times sigma lead time squared. And you plug them in and calculate, you get 163.53. So 164 is your reorder point for this case. Here's annual holding cost and safety stock. What is the relationship? As you can see here, it's kind of steadily increasing and then exponentially increasing as at some point. So what this is implying is that the service level is important or it doesn't really cost you that much until a certain point. For example, 97%, it was manageable. However, after a certain point, for example, 98 or 99%, the safety stock cost exponentially increases, and therefore, a business has to be very careful about setting the service level so that you might not incur lots of costs for your safety stock. I hope this helped you to understand the policies and implications of safety stock. Thank you.